Something emerged from behind the sun on November 1st, 2025, and what scientists saw left them speechless. For months, the world had been tracking 3I Atlas, the third known visitor from beyond our solar system. We watched it approach. We watched it dive toward the sun. And then, for weeks, we watched nothing as it disappeared behind our star's blinding glare during its closest approach on October 29th. But when it reappeared, something was different. Fundamentally different. Before we dive into what happened, let me ask you something. What would you do if you discovered something that challenged everything we thought we knew about objects from interstellar space? Would you share it immediately with the world, or would you hold it back? NASA made their choice, and that choice is raising questions that deserve answers. Here's what we know. On October 2nd and 3rd, 2025, as 3I Atlas passed within just 29 million kilometers of Mars, NASA's Mars Reconnaissance Orbiter turned its most powerful camera toward the visitor. The HiRISE camera, capable of resolving details down to 30 kilometers per pixel, captured what should be the clearest images we have of this interstellar object. Images that could answer fundamental questions about what 3I Atlas really is. Those images were taken over 40 days ago, and as of today, November 15th, 2025, NASA still hasn't released them to the scientific community or the public. Think about that for a moment. We have images that are 3 times sharper than anything the Hubble Space Telescope captured. Images taken from a side angle that could reveal the true geometry of the mysterious structures extending from this object. Images that could show us the actual size of its nucleus, the shape of its jets, the nature of its tail, and they're sitting in a server somewhere, classified as, quote, NASA-wide news, requiring special approval for release. Harvard professor Avi Loeb, one of the leading scientists studying 3I Atlas, has been publicly calling for NASA to release these images. His frustration is palpable and honestly understandable. In his own words, science should not be held hostage by bureaucracy. These are time-sensitive observations. Every day that passes is a day we could be planning follow-up observations, adjusting our telescopes, coordinating international efforts to understand what we're seeing. But here's where it gets interesting. NASA's HiRISE website continues to release new images of Mars every single day. Routine shots of craters, dunes, geological formations, business as usual. But when it comes to 3I Atlas, there's a special notice, and I quote, "Any images of the interstellar comet 3I Atlas are considered NASA-wide news. Because the federal government is in shutdown, communications of NASA news have been suspended." Now, the government shutdown ended days ago. The excuse expired, yet the images remain unreleased. Why single out 3I Atlas? Why treat it differently from every other astronomical observation? What did those images show that requires this level of deliberation? If you're finding this intriguing, make sure to hit that subscribe button, because what I'm about to tell you gets even stranger. And trust me, you'll want to follow this story as it develops. Let's back up for a second and talk about what makes 3I Atlas so special in the first place. This isn't just another comet. This is only the third object we've ever confirmed came from another star system. The first was Oumuamua in 2017, that cigar-shaped visitor that tumbled through our solar system and sparked years of debate. The second was 2I Borisov in 2019, which looked and behaved exactly like we'd expect a comet to behave. Then came 3I Atlas, discovered on July 1st, 2025, by the Atlas Survey Telescope in Chile. From the beginning, something felt off. Its orbit was clearly hyperbolic, meaning it came from interstellar space. That much was certain. But unlike 2I Borisov, which played by all the rules we understand, 3I Atlas started showing behaviors that didn't quite fit the textbook definition of a comet. The Hubble Space Telescope captured images back in July that showed something unusual. Instead of a normal cometary tail pushed away from the sun by solar radiation, there was this structure extending toward the sun, an antitail. Now, antitails can happen with regular comets under specific geometric conditions, so initially, this wasn't cause for alarm. But then came the perihelion passage, October 29th, 2025. The moment 3I Atlas reached its closest point to the sun, about 130 million miles away, just inside the orbit of Mars. This is when comets typically put on their best show. The sun's heat causes ices to sublimate, creating spectacular tails and sometimes causing the comet to fragment entirely. Scientists had their telescopes ready, their instruments calibrated, waiting to see what 3I Atlas would do. What they saw was unprecedented. And that brings us back to those missing images. The HiRISE camera caught 3I Atlas during this critical period, from the perfect vantage point. While Hubble had captured an edge-on view back in July, seeing the antitail from just 10 degrees off the sun's direction, HiRISE would have given us a side view. A completely different perspective that could reveal the three-dimensional structure of whatever was happening. Professor Loeb emphasizes this point repeatedly. A picture is worth 1,000 words, he says. And he's right. We can theorize all we want, but actual data, actual images, those are what drive science forward. So why the delay? The official explanation keeps shifting. First, it was the government shutdown. Now, that excuse is gone. Some suggest it's bureaucratic processing time. Others wonder if there's internal debate about what the images show, whether they need additional analysis before release, whether the implications require careful handling. But here's what's not in dispute. Every single day that passes is a day lost. 3I Atlas is moving away from us now, getting dimmer, harder to observe. Follow-up observations need to happen soon, before it becomes too faint for detailed study. And those follow-up observations should be informed by the HiRISE data. The scientific method works best when information flows freely. When scientists around the world can examine data, offer interpretations, challenge each other's conclusions. When one institution holds back information, especially information this significant, it raises eyebrows. And it's not just Professor Loeb raising concerns. Scientists worldwide are watching this situation, wondering when they'll get access to data that should rightfully belong to the entire scientific community. Now, I'm not here to tell you what to think. I'm not claiming this is some grand conspiracy or cover-up in the traditional sense. But I am pointing out facts. Facts that deserve scrutiny. 40-plus days is a long time to sit on images that could be scientifically game-changing. Long enough to make people wonder what those images might show. Long enough to fuel speculation. Because here's the thing. When 3I Atlas emerged from behind the sun in early November, ground-based telescopes immediately started tracking it again. And what they're seeing is raising even more questions than before. Before I tell you about those observations, if you're enjoying this deep dive into one of the most mysterious objects ever to visit our solar system, please take a second to like this video. It helps more people discover this story, and honestly, this is something everyone should know about. The images that we do have access to, the ones taken after perihelion by ground-based observatories, show something that defies easy explanation. And when you combine what we're seeing now with what we saw before, with the data we have versus the data we're waiting for, a picture emerges that is anything but ordinary. 3I Atlas isn't just passing through. It's performing, putting on a display that has astronomers scrambling to explain what they're witnessing. And somewhere, in a NASA database, there are images that might hold the key to understanding it all. The question isn't whether those images will eventually be released. They will be. The question is what they'll show when they finally see the light of day. And more importantly, why it took so long for the public and the scientific community to see them. This is just the beginning of the story. What happened after 3I Atlas emerged from the sun's glare is even more bizarre than the bureaucratic delays. We're talking about structures that shouldn't exist, behaviors that don't match any comet we've ever studied, and measurements that have scientists doing double takes. On November 9th, 2025, astronomers M. Yeager, G. Riemann, and E. Prosperi released an image that stopped the scientific community in its tracks. It wasn't the fact that they'd captured 3I Atlas after perihelion. That was expected. What wasn't expected was what the image revealed. Multiple jets, at least 7 distinct structures extending from the interstellar visitor. But here's what made this extraordinary. Some of those jets were pointing in the wrong direction. Let me explain why this matters. When a comet approaches the sun, solar radiation heats its icy surface. The ice sublimates, turns directly from solid to gas, and this gas carries dust particles with it, creating the classic cometary tail. Physics dictates that this tail should point away from the sun, pushed by solar radiation pressure and the solar wind. This is basic comet behavior. Textbook stuff. We've observed it thousands of times. 3I Atlas decided to ignore the textbook. The images showed jets extending toward the sun. Not just one. Multiple anti-solar jets, defying the very physics that should govern their behavior. And surrounding all of this, a massive, glowing halo extending outward for 500,000 kilometers. 500,000 kilometers. That's roughly the distance from the Earth to the Moon. And that's just the visible halo. Professor Loeb, analyzing these images, counted at least 7 distinct jets. 7 separate structures, each one representing material being ejected from the surface of this object. Some pointing away from the sun, as expected. Others pointing directly toward it. Now, before you jump to conclusions, let's be fair. Anti-solar jets aren't completely unknown in cometary science. They can occur under very specific geometric conditions, when you're viewing a comet from a particular angle, and the dust particles are distributed in certain ways. Perspective can play tricks on our eyes. But here's where it gets complicated. We're not talking about a single anti-tail viewed from one angle. We're talking about multiple structures, observed from different vantage points, by different telescopes, all showing the same thing. A complex, almost organized pattern of jets extending in multiple directions. 2 days later, on November 11th, another image hit the astronomical community. This one from Frank Niebling and Michael Buchner, and it told the same story, but with even more clarity. 2 prominent anti-tail jets heading toward the sun. One larger tail extending in the opposite direction, and all of it part of this intricate symmetrical structure that doesn't quite match anything we've seen before. The Virtual Telescope project, run by Gianluca Masi, has been tracking 3I Atlas for days now. He's released a series of images showing the evolution of these structures. And here's what's fascinating. The tail is growing. Visibly, measurably growing longer with each observation. Day by day, these structures are extending further into space. Now, comets do develop tails as they approach and pass the sun. That's normal. What's not normal is the complexity. What's not normal is the geometric precision. What's not normal is having multiple jets that seem to maintain their distinct identities rather than blending into a diffuse cloud. Think about it this way. Imagine you're heating an ice cube. As it melts, water runs off in all directions, following gravity and the shape of the surface. It's chaotic, unpredictable, random. Now imagine that ice cube producing 7 distinct streams of water, each one maintaining its direction, its shape, its identity. That's odd. That requires explanation. Some scientists are proposing that we're seeing the result of specific ice pockets on the surface of 3I Atlas. As the sun heats different areas, different vents open up, each one producing its own jet. The direction of these jets would depend on the orientation of the surface, the composition of the ice, the rotation of the object. It's a reasonable explanation, and it might be correct. But then there's another possibility. One that Professor Loeb has been careful to articulate without making definitive claims. What if these aren't passive vents? What if these are active exhaust points? Hold on. Before you dismiss that idea, let's look at the numbers. When ice sublimates from a comet's surface, the gas escapes at relatively low velocities. We're talking a few hundred meters per second at most. That's the speed dictated by the physics of sublimation. The spectroscopic measurements that scientists can make, measuring the Doppler shift of molecular lines, should show velocities in that range if we're looking at a natural comet outgassing. But if those jets were being produced by something else, by thrusters for example, the velocities would be different. Significantly different. We'd expect to see speeds of several kilometers per second, an order of magnitude higher. Here's the thing, those spectroscopic measurements can be made. Right now. With telescopes that are currently observing 3I Atlas, we could know, definitively, whether these jets are moving at comet speeds or at something faster. We could settle this question with data, but we need those observations to happen soon. Because 3I Atlas is moving away, getting dimmer every day. The window for detailed spectroscopy is closing, and that brings us back to those HiRISE images sitting in NASA's database. Those images would show us the side view of these jets. They would reveal their three-dimensional structure. They would tell us if there's a central nucleus with vents, or if the geometry suggests something else entirely. If you're starting to see why this is frustrating for scientists, hit that like button. This story needs to reach more people. The more eyes on this, the more pressure there is for transparent, open science. Let's talk about what makes these jets so unusual from a structural standpoint. In typical comets, jets are ephemeral. They form, they dissipate, they change shape rapidly as the comet rotates, and different areas get exposed to sunlight. They're dynamic, constantly evolving. What we're seeing with 3I Atlas is different. These jets appear stable. They maintain their form over multiple observation periods. They extend for enormous distances, well over 1 million kilometers in some cases, without dissipating into the background. That level of collimation, that's the technical term for how focused and beam-like these jets are, is unusual. Not impossible, but unusual. It suggests either a very specific surface structure channeling the gas, or a very specific mechanism producing the jets in the first place. And then, there's the symmetry. Look at the images carefully. Multiple jets, but they're not randomly distributed. There's a pattern, an organization to their arrangement. Some scientists see this and think rotating nucleus with specific vent locations. Others see it and wonder. The question isn't whether natural processes can produce jets. They can. They do. All the time. The question is whether natural processes can produce this specific pattern of jets, with this specific geometry, with this specific behavior, all from an object that came from interstellar space and is unlike any comet we've studied before. Science works by building models, making predictions, and testing those predictions against observations. Right now, we have multiple models. The natural comet model says 3I Atlas is an icy body, probably somewhat different in composition from solar system comets because it formed around a different star, but fundamentally behaving according to known physics. That model predicts certain things. It predicts sublimation velocities in a specific range. It predicts certain spectral signatures from the gases being released. It predicts fragmentation is possible, maybe even likely, after the intense heating near perihelion. And then there's the other model. The one that says maybe, just maybe, we're not looking at a natural object. That model makes different predictions. Higher velocities, possible course corrections, anomalous accelerations not explained by outgassing. Here's what's interesting. We're starting to see data that fits the second model, and that should make everyone pay attention. On October 31st, just 2 days after perihelion, a report emerged showing evidence of non-gravitational acceleration of 3I Atlas. That means the object wasn't following a purely ballistic trajectory. Something was pushing it, changing its course, however slightly. Now, comets can show non-gravitational acceleration. The rocket effect from outgassing can push them slightly off their predicted orbits. This happens. It's documented. But the magnitude and timing of the acceleration detected with 3I Atlas raised eyebrows. Was it just vigorous outgassing? Quite possibly. Or was it something else? The data is there. It's being analyzed. And the scientific community is divided on what it means. This is how science should work. Multiple hypotheses, rigorous testing, open debate. What's frustrating is when data that could help resolve these questions is held back, delayed, kept from the researchers who need it most. Every day, without the HiRISE images, is another day of uncertainty. Another day where we can't definitively say what these jets are, where they're coming from, what's producing them. But we do know this. Whatever 3I Atlas is, it's putting on a show unlike anything we've seen from an interstellar visitor before. 7 distinct jets, a growing tail, a massive halo, complex structures that maintain their integrity across millions of kilometers. And somewhere in those structures, in the geometry of those jets, in the velocities we haven't measured yet, lies the answer to what this object really is. The question is whether we'll get that answer before 3I Atlas becomes too faint to study in detail, whether the data will be released in time, whether science will triumph over bureaucracy, because what comes next in this story gets even stranger. We haven't even talked about the radio signal yet. October 24th, 2025, 5 days before perihelion. While the world's optical telescopes were pointed at 3I Atlas, capturing images in visible light, a radio telescope in South Africa was listening, the Meerkat Radio Telescope Array, one of the most sensitive radio observatories in the southern hemisphere. 74 individual dishes working in concert, capable of detecting the faintest whispers of radio emission from across the cosmos. And on that day, it heard something from 3I Atlas. The announcement didn't come until November 8th, 2 weeks after the detection. And when it did, it sent ripples through the astronomical community. For the first time, we had detected radio emissions from this interstellar visitor. Not reflected signals, not scatter. Active radio absorption lines indicating the presence of specific molecules being shed by the object. The frequency? 1.665 to 1.667 gigahertz. Now, if you're not deeply immersed in radio astronomy, that number might not mean anything to you. But to those who study the cosmos through radio waves, that frequency is significant. Very significant. That's the characteristic frequency of hydroxyl radicals, OH molecules, one oxygen atom bonded to one hydrogen atom. And what makes this particularly interesting is where that frequency sits in the electromagnetic spectrum. It's in what's called the water hole, the region between 1.42 gigahertz, where hydrogen emits naturally, and 1.67 gigahertz, where hydroxyl radicals absorb and emit. This narrow band of frequencies has long been considered one of the most promising places to search for signals from technological civilizations. It's relatively quiet, cosmically speaking, a natural choice for communication if you wanted your signal to be heard above the background noise of the universe. Does that mean the signal from 3I Atlas is artificial? No, absolutely not. Let me be very clear about this. Hydroxyl radicals are common in comets. As water ice sublimates and breaks down under solar radiation, OH molecules are a natural byproduct. Detecting them is exactly what we'd expect from a comet near the sun. But here's what makes this detection noteworthy. It's the first radio detection from 3I Atlas since its discovery. For months, this object was observed optically, but radio telescopes hadn't picked up anything definitive. Then, 5 days before, perihelion, at the moment of peak solar heating, the Meerkat Array detects a clear signal at 1.666 gigahertz. The timing is perfect for a comet outgassing water. The frequency matches exactly what hydroxyl radicals should produce. By every conventional measure, this is a natural, expected phenomenon. And yet, the detection raised questions, not because of what it showed, but because of what we don't know about the object producing it. Is this a garden-variety icy comet from another star system? Or is it something that's designed to look like a garden-variety icy comet? Professor Loeb has been careful in his public statements about this detection. He acknowledges it's consistent with natural outgassing. He also points out that if you wanted to create a plausible cover for an artificial object traveling through a solar system, coating it in ice and allowing natural sublimation to occur would be a pretty effective strategy. It sounds like science fiction. And maybe it is. But here's the thing about science. We can't dismiss possibilities just because they sound unlikely. We test them. We gather data. We let the evidence guide us. So, what would distinguish between natural OH emissions and something else? Velocity, for one thing. If you can measure the Doppler shift of those radio lines precisely enough, you can determine how fast the OH molecules are moving away from the source. Natural sublimation produces specific velocities. Artificial venting, if it existed, might produce different velocities. Have those detailed velocity measurements been published? Not yet. The detection was announced, but the full analysis of the spectral lines is still ongoing. Or at least, that's what we're told. And this is where the pattern starts to become frustrating. Another piece of crucial data, still being analyzed, still being processed, still not available to the wider scientific community for independent verification and study. If you're noticing a trend here, so am I. Hit that subscribe button because this story is far from over, and you're going to want to follow how this unfolds. Let's talk about what else makes the 1.666 gigahertz detection interesting. That specific frequency has historical significance in the search for extraterrestrial intelligence. In fact, there's a famous incident that some of you might remember, the WOW signal. August 15th, 1977. The Big Ear radio telescope in Ohio detected a strong narrowband radio signal at 1.420 gigahertz, the hydrogen line. It lasted 72 seconds and was so unexpected, so anomalous, that the astronomer reviewing the data wrote "wow" in the margin. To this day, that signal has never been satisfactorily explained, and it's never been detected again, despite decades of follow-up observations. Now, I'm not saying 3i Atlas is related to the WOW signal. The frequencies aren't exactly the same, the circumstances are completely different, and hydroxyl emissions are far more common than narrowband hydrogen signals. But it is interesting that an interstellar object is producing radio emissions in the water hole, a region of the spectrum that's been central to SETI research for half a century. Coincidence? Almost certainly. But coincidences can be thought-provoking. Here's what we know for certain about the Meerkat detection. The hydroxyl radical absorption lines were centrally concentrated in the observations. That means the emission was coming from near the nucleus of the object, not from a diffuse cloud spread across millions of kilometers. It confirms that 3i Atlas has a solid core that's shedding material, consistent with either a comet or a designed object with an ice coating. The fact that the signal was only detected on October 24th is also telling. This was during the period of maximum solar heating, when sublimation would be at its peak. If 3i Atlas is a natural comet, this is exactly when we'd expect to see the strongest OH emissions. The timing fits, but the timing also fits another scenario. If an object needed to perform maneuvers to adjust its trajectory or orientation, the perihelion passage would be the perfect time to do it. Any anomalous activity could be attributed to natural outgassing. Any acceleration could be explained away as the rocket effect from sublimating ice. I'm not claiming that's what happened. I'm pointing out that both explanations fit the observed data equally well. And without more detailed measurements, without spectroscopic analysis of those jet velocities, Without the HiRISE images showing the geometry of the mass ejection, we can't definitively choose between them. This is the challenge of studying objects from interstellar space. They're unique. We can't compare 3i Atlas to a catalog of similar objects because we don't have a catalog. Oumuamua was one data point. 2i Borisov was another. Now we have 3i Atlas. 3 objects. 3 very different behaviors. From this, we're supposed to construct a theory of what interstellar objects typically look like. It's like trying to understand what cars are by examining 3 random vehicles. You might get a bicycle, a motorcycle, and a semi-truck. Are those all the same category? Well, they're all transportation, but they're fundamentally different in design and purpose. Maybe 3i Atlas is just an unusual comet. Maybe the jets, the radio signal, the non-gravitational acceleration, the complex structure, maybe all of it has natural explanations that we just haven't fully worked out yet. Or maybe we're witnessing something else. Something that's been traveling between stars for who knows how long, entering our solar system at this precise moment in human history when we finally have the technology to detect it, to track it, to study it. The radio detection adds another piece to this puzzle. But like all the other pieces, it doesn't give us a clear picture on its own. We need context. We need the full data set. We need those velocity measurements, those spectroscopic analyses, those high-resolution images. And we need them before 3i Atlas fades from view. Because here's something that hasn't gotten enough attention. This object has been transforming throughout its passage. When it emerged from behind the sun, it wasn't the same object that went in. The structure changed. The jets appeared. The tail grew. Something fundamental shifted during that perihelion passage. Was it thermal stress causing the surface to crack and vent? Was it tidal forces from solar gravity? Was it radiation damage altering the surface composition? All of those are plausible for a natural object. But there's another possibility. One that sounds like science fiction, but deserves consideration given the anomalies we're observing. What if the perihelion passage was a planned maneuver? What if 3i Atlas used the sun's gravity to alter its trajectory, to adjust its course for whatever comes next? Gravitational slingshots are routine in space exploration. We use them all the time to send probes to the outer solar system. Pioneer, Voyager, New Horizons, all of them leveraged planetary gravity to gain speed and change direction. It's efficient, it's elegant, and it requires precise timing and navigation. Could a natural object execute a gravitational slingshot? Not deliberately, no. But if an object from interstellar space happened to have a trajectory that brought it close to our sun, the gravitational assist would occur whether the object was natural or artificial. The question is whether the trajectory was deliberate or coincidental, and to answer that, we'd need to track any changes in velocity or direction that can't be explained by gravity and natural outgassing alone. Which brings us back, once again, to the data we're waiting for. The measurements we need. The images sitting in a NASA database. The 1.666 gigahertz signal is fascinating. It confirms 3i Atlas is shedding hydroxyl radicals, probably from water ice. It tells us the object has volatile materials that respond to solar heating. It gives us a radio fingerprint that can be studied and analyzed. But it doesn't answer the fundamental question. What is this object? For that, we need the complete picture, and we're still waiting. Let's talk about what shouldn't be possible. When the Hubble Space Telescope captured its image of 3i Atlas back on July 21, 2025, astronomers noticed something that violated their expectations. The object had a tail, yes, but it was pointing in the wrong direction, toward the sun instead of away from it. An anti-tail, a structure extending from the comet's nucleus sunward, defying the basic physics of how cometary tails are supposed to behave. Now, I mentioned earlier that anti-tails can occur naturally under specific viewing geometries. That's true. When you observe a comet from certain angles, dust particles along its orbital plane can create the illusion of a tail pointing toward the sun. It's a perspective effect, like railroad tracks appearing to converge in the distance. But what Hubble saw wasn't a perspective illusion. The observation was made from a viewing angle just 10 degrees off the sun's direction relative to 3i Atlas. This was essentially an edge-on view of whatever structure was extending from the object. And that structure was real, physical, extending toward the sun against all the forces that should be pushing it away. Here's why this matters. Solar radiation pressure is powerful. Photons from the sun carry momentum, and when they hit dust particles, they push them, always outward, always away from the sun. This is what creates the classic cometary tail, that beautiful streamer that always points away from the solar direction, regardless of which way the comet is moving. For material to move toward the sun, it needs to be traveling with significant velocity in that direction. It needs to be actively propelled, not passively swept. The sublimation of ice doesn't typically do this. When ice turns to gas on a comet's surface, it generally expands in all directions, and then solar pressure takes over, pushing everything anti-solar. So what could create a sustained jet of material moving sunward? That's the question that has astronomers debating. One possibility is rotation. If 3i Atlas is spinning, and if there's a vent or active area on its surface oriented toward the sun at specific times in its rotation, it could produce jets in that direction. The momentum from the expanding gas could overcome solar radiation pressure, at least initially, creating these sunward structures. It's plausible. It requires specific conditions, a specific geometry, a specific rotation rate, and axis orientation. But it's possible. The other possibility is more unsettling. What if those aren't passive vents? What if they're active thrusters, deliberately oriented to produce thrust in specific directions? Before you dismiss that idea, consider this. If you were traveling through interstellar space and needed to navigate, how would you do it? You couldn't use chemical rockets. You'd run out of fuel millennia ago. Solar sails wouldn't work in the darkness between stars. But if you had a store of volatile material, ice for example, you could use solar heating to sublimate it in controlled bursts. Natural-looking outgassing that's actually precisely timed propulsion. It would be elegant. It would be efficient. And it would be almost impossible to distinguish from natural cometary activity unless you measured the velocities very precisely and track the trajectory changes with extreme accuracy, which again requires the data we're still waiting for. Let me paint you a picture of what we observed. Before perihelion, 3i Atlas had this anti-tail structure visible in the Hubble images. One major feature, anomalous, but not beyond explanation. Then came the perihelion passage, October 29th. The object dove to within 130 million miles of the sun, experiencing intense heating, intense gravitational stress, intense radiation. And when it emerged, it had transformed. Not one anti-tail, multiple jets, at least 7 distinct structures, a massive halo extending 500,000 kilometers, a growing tail that's been measurably extending day by day, complex geometry that's being maintained across millions of kilometers of space. What happened during that perihelion passage? What changed? If 3i Atlas is a natural comet, the explanation is thermal stress. The sun's heat penetrated deep into the nucleus, creating new cracks, opening new vents, releasing trapped gases. The intense radiation altered the surface composition, possibly exposing fresh ice or triggering chemical reactions that changed how the object outgasses. Comets do fragment and change during close solar approaches. We've seen it happen. Comet Shoemaker-Levy 9 broke into multiple pieces before impacting Jupiter. Comet Ison disintegrated during its perihelion passage. Thermal stress can absolutely cause dramatic changes in cometary structure. But here's what's interesting about 3i Atlas. It didn't fragment. It didn't break apart. it transformed into something more complex, more organized, more structured than what went in. That's not typical fragmentation behavior. When comets break apart, they become messier, more chaotic. They split into multiple pieces that drift apart, each following slightly different trajectories. They don't develop 7 symmetrically arranged jets that maintain their coherence over time, unless, of course, the object was designed to withstand the perihelion passage, unless the transformation was planned, anticipated, part of the mission profile. I know how that sounds. I know it sounds like science fiction, but consider the alternative. Consider what we're being asked to accept if this is purely natural. An interstellar comet, different from the one other interstellar comet we've studied in detail, 2I Borisov. Different in its composition, its behavior, its response to solar heating. It happens to have a trajectory that brings it close to our sun. It happens to develop anti-solar jets at just the right time. It happens to undergo a dramatic transformation at perihelion that makes it more complex rather than fragmenting it. It happens to show non-gravitational acceleration that can't be fully explained by conventional outgassing models. That's a lot of coincidences. Now, don't get me wrong, coincidences happen. Nature is full of unlikely events that occur through pure chance. The universe is vast, and statistical improbabilities become certainties given enough opportunities. But science demands we consider all possibilities. And right now, we have 2 competing explanations that both fit the observed data. We need more data to distinguish between them. Let's talk about what that transformation tells us, regardless of which explanation is correct. The fact that 3I Atlas changed so dramatically means it was holding something back. There was potential energy, whether thermal, gravitational, or chemical, stored in that object that got released during perihelion. For a natural comet, that stored energy would be solar heat penetrating the insulating outer layers, reaching subsurface ice, building pressure until it found release through new vents and fractures. For an artificial object, that stored energy could be whatever power source has been keeping it operational. For the thousands or millions of years it's been traveling through interstellar space, finally activated or ramped up during the solar passage. Both explanations require assumptions. The natural explanation assumes this interstellar comet behaves like solar system comets, despite forming in a completely different stellar environment. The artificial explanation assumes technological civilizations exist and build interstellar probes. Which assumption is more reasonable? That depends on your priors, your understanding of astrobiology, your assessment of the Drake equation, and the Fermi paradox. What we can say objectively is this: 3I Atlas is behaving in ways that are challenging to explain with simple models. It's at the edge of what natural processes can plausibly produce. And the more anomalies that pile up, the more carefully we need to examine our assumptions. The anti-tail isn't just a curiosity. It's a signature, a fingerprint of whatever process is ejecting material from this object, combined with the radio signal, the multiple jets, the non-gravitational acceleration, the geometric complexity. It paints a picture of an object that's far more active, far more dynamic than a typical inert space rock. And here's something that hasn't been emphasized enough. 3I Atlas survived perihelion intact. Many comets don't. The thermal stress, the tidal forces, the radiation, it's enough to tear a loosely bound icy body apart. But 3I Atlas held together. More than that, it emerged more active than before. That suggests structural integrity. That suggests either a comet nucleus with unusual strength, held together by something more than just gravity and frozen volatiles, or it suggests an object with an internal structure designed to withstand such stresses. We won't know which until we have better data on the object's size, shape, and composition. And the best data we have, those HiRISE images from Mars orbit, are still locked away. Every time I mention those images, I feel like I'm beating a dead horse. But this is important. Those images represent our best chance to see the three-dimensional structure of the jets and anti-tail. They would show us if there's a central nucleus or a more distributed structure. They would reveal details that could settle many of these questions. The fact that they're being held back, whether for bureaucratic reasons or something else, is hampering scientific progress at a critical moment. If you've made it this far in the video, thank you. This is complex material, and the fact that you're still engaged means you understand why this matters. Please hit that like button. Share this video. This story needs more attention, and your engagement helps make that happen. As 3I Atlas moves away from the sun, its activity should theoretically decrease. Less solar heating means less sublimation, which means the jets and tail should fade. That's what happens with normal comets. So the question is, will 3I Atlas follow that script? Or will it continue to surprise us? The observations over the coming weeks will tell us a lot. If the jets persist even as solar heating decreases, that would be very difficult to explain with natural outgassing. If the object shows any course corrections or anomalous accelerations that can't be attributed to the rocket effect, that would raise serious questions. We're in a unique moment. An interstellar visitor is passing through our solar system, close enough to study in detail, active enough to reveal its nature through its behavior. This won't last forever. In a few months, 3I Atlas will be too far away, too faint for detailed observations. Whatever it is, whatever secrets it holds, we have a limited window to discover them, and that window is closing. Step back with me for a moment. Let's look at the bigger picture. We are living in the first era of human history where we can detect and study objects from other star systems. For thousands of years of astronomy, we looked at the stars and wondered what was out there. Objects from other stars were theoretical, imagined, beyond our reach. That changed in 2017 with Oumuamua, then 2019 with 2I Borisov, now 2025 with 3I Atlas. In less than a decade, we've gone from 0 confirmed interstellar objects to 3. Oumuamua was the wake-up call, elongated, tumbling through space, showing non-gravitational acceleration that sparked years of debate. Was it a comet? A nitrogen iceberg? A light sail? We still don't have consensus. 2I Borisov was the textbook case. It looked like a comet, acted like a comet. It was comforting. It told us other star systems make icy bodies similar to ours. And then came 3I Atlas, different from both, more active than Oumuamua, more complex than 2I Borisov, displaying behaviors that don't quite fit either category. One interpretation is natural variation. We're seeing the beginning of a statistical sample. As we detect more visitors, we'll understand what's normal and what's anomalous. But there's another interpretation. What if some of these visitors are not natural at all? Professor Loeb has been vocal about this possibility. Not to sensationalize, but because scientifically, we cannot rule it out. If there's even a small probability we're observing technology from another civilization, we have an obligation to investigate thoroughly. Think about the implications if 3I Atlas is artificial. Not flying saucers, but a probe, perhaps autonomous, perhaps ancient, traveling through the galaxy. What would that mean? It would mean we're not alone. It would mean another civilization achieved interstellar capability. It would mean the galaxy is, or was, populated by technological species. That's profound. That changes everything about how we see ourselves, our place in the cosmos, our future. But it raises questions. If interstellar probes are passing through, why no contact? Why the ambiguity? Maybe contact isn't the goal. Maybe these are survey missions, data collection, observation without interference. Or maybe 3I Atlas is exactly what it appears to be, an unusual but natural interstellar comet teaching us about galactic diversity. Science works best when we hold multiple hypotheses and let data guide us. Right now, we have intriguing anomalies, behaviors that challenge simple explanations. But we don't have proof. What frustrates scientists is when institutional barriers slow this process, when data that could resolve questions is delayed for bureaucratic reasons. The HiRISE images are one example. It's part of a larger pattern in how we handle potential extraordinary discoveries. There's a tendency toward caution, toward controlling the narrative, but extraordinary discoveries require extraordinary transparency. That information belongs to all humanity. The very fact we're having this conversation is significant. A Harvard professor can publicly suggest we consider the possibility of interstellar technology and be taken seriously. That represents a shift. For decades, extraterrestrial intelligence was almost taboo in mainstream science. That's changing. Organizations like the Galileo Project are bringing rigorous methodology to the search for technological signatures. 3i Atlas is pushing that conversation forward. It's forcing us to think about what we'd expect to see if interstellar probes exist, what signatures they'd leave. Let's talk statistics. Based on detection rates, we see roughly one interstellar object every couple of years. But that's just what we're detecting. Our surveys miss the vast majority. Estimates suggest thousands of interstellar objects might be in our solar system at any time. Most are small, inert, unremarkable. But statistically, if even a tiny fraction of civilizations send out probes, we should encounter technological artifacts. The galaxy is 13 billion years old, hundreds of billions of stars. If even one in a million hosts technological civilization, and if a tiny percentage create probes, the galaxy could be saturated with artificial objects. This is the Fermi paradox. If intelligent life is common, where is everybody? Maybe we're seeing it right now, too cautious to recognize it. Or maybe the galaxy is empty of other technological life, and every anomaly has a natural explanation. Both possibilities are humbling. Both reshape how we think about our place in the universe. What we can say is that 3i Atlas has given us an opportunity, a chance to test assumptions, push observational capabilities, practice systematic investigation. And those discoveries are coming. The Vera Rubin Observatory will revolutionize our ability to detect interstellar objects. It's expected to find dozens of new visitors in the coming decade. Imagine having not 3 data points, but 30, or 300, building a real statistical sample of what passes through our solar system. Some will be mundane, but some might display the same anomalies we're seeing with 3i Atlas. With larger samples, we'll distinguish between natural variation and genuine outliers. If you found this thought-provoking, make sure you're subscribed. This story is still unfolding. As more data comes in, we'll keep analyzing, questioning, and searching for answers. Because that's what this is about. Asking questions, following evidence, remaining open to possibilities we might not have considered. 3i Atlas is teaching us how to do that, and the lessons we're learning now might be crucial for understanding what comes next. So, where does this leave us? It's November 15th, 2025. 3i Atlas is moving away from the sun, fading from view day by day. The window for detailed observations is closing, and we still don't have definitive answers. We don't know the exact size of its nucleus. We don't know the composition of those jets. We don't know the velocities of the ejected material. We don't have the HiRISE images that could illuminate these mysteries. What we do know is that 3i Atlas is unlike anything we've encountered before. More active than Oumuamua, more complex than 2i Borisov, more enigmatic than any comet from our own solar system. And that ambiguity is both frustrating and exhilarating. Frustrating because we have incredible technology. Telescopes that can peer billions of light years into space, detect planets around distant stars, image black holes. Yet, here's an object in our immediate neighborhood, and we're still piecing together what it is from incomplete data. But exhilarating, because this is how discovery works. This is the frontier. Not everything fits into established categories. Sometimes nature surprises us, challenges us, forces us to expand our thinking. The story of 3i Atlas is really about how we approach the unknown. Do we default to conventional explanations, or do we remain open to unconventional possibilities? The answer is both. We need the rigor of conventional science, the careful analysis, the demand for extraordinary evidence. But we also need imagination to consider alternatives, to follow data wherever it leads. Professor Loeb has been walking that line. He's not claiming alien technology. He's saying we should consider that possibility seriously and test it rigorously. That's not sensationalism. That's good science. The truth is, we should be comfortable with discomfort. The universe is strange. Quantum mechanics is strange. Dark matter is strange. Why should the possibility of other technological civilizations be the one strange thing we refuse to consider? It shouldn't be. And increasingly, it isn't. The scientific community is recognizing that the search for technosignatures is legitimate inquiry. NASA has programs dedicated to it. The conversation is changing. 3i Atlas is part of that change. Even if it's completely natural, the discussions it's sparked, the methodologies being developed, the willingness to ask uncomfortable questions, all of that moves the field forward. So, what happens next? What should we watch for? First, those HiRISE images need to be released. If you value scientific transparency, make your voice heard. Contact NASA. Ask why images taken over 40 days ago are still being held. Second, follow the spectroscopic observations. Research teams are analyzing the jets, measuring velocities, identifying molecular signatures. When published, they'll provide crucial constraints on what 3i Atlas is. Third, watch for trajectory changes. If 3i Atlas shows course corrections unexplained by gravity and conventional outgassing, that would be significant. Precision tracking will pick up any anomalies. And fourth, stay informed about the broader search. The Vera Rubin Observatory is beginning survey work. We'll discover many more visitors from beyond our solar system. Each one is a data point. This channel will continue covering these discoveries. We'll analyze data as it comes in and keep asking the hard questions. But I need your help. If you found this deep dive valuable, please subscribe to this channel. Click that notification bell and share this video with anyone interested in this story. The algorithm rewards engagement. The more people who watch, like, comment, and share, the more this content reaches others who are curious. This story deserves widespread attention. We're living through a remarkable moment. For the first time, we can detect and study visitors from other star systems. We're developing tools to distinguish between natural objects and potential technology. We're asking questions that would have been science fiction a generation ago. 3i Atlas is teaching us how to navigate this new reality, how to balance skepticism with openness, how to demand evidence while acknowledging uncertainty, how to pursue truth even when it leads to uncomfortable questions. The object itself will fade from view in coming months. It'll become too distant for detailed observation. It'll continue its journey through the galaxy, but the questions it's raised will remain. The methodologies we've developed will be refined. The conversations will continue. Because this isn't about one object. It's about how we approach understanding in a universe full of mysteries. We're in the early stages of exploring our cosmic neighborhood. We've barely scratched the surface. And every anomaly, every unexplained observation is an opportunity to learn. Maybe 3i Atlas is a comet, an unusual, complex, highly active interstellar comet showing us the diversity of objects formed around other stars. If so, that's fascinating. Or maybe it's something else, something that will force us to reconsider our assumptions about what's possible, what exists in the galaxy. Either way, we win. either way, we learn. That's the beauty of science. It's not about confirming what we believe. It's about discovering what we don't know. It's about being surprised by reality. 3i Atlas has surprised us. It's challenged our expectations. It's given us puzzles to solve and mysteries to contemplate. And isn't that exactly what we should want from a visitor from the stars? Thank you for watching. Thank you for your curiosity, your engagement, your willingness to explore complex questions. Keep looking up. Keep asking questions. And keep demanding transparency from institutions that hold the data we need. The story of 3i Atlas isn't over. In many ways, it's just beginning. Subscribe, like, share, and let's see where this journey takes us. Because the universe is full of wonders, and we've only just begun to discover them.